Alright, so how do you solve Leontief preferences? Well, the problem here is you can write down Lagrangian, but you can't take derivatives. Why? Because you can't take a derivative of a function that looks like this, a minimum kind of thing. So where do you go? You go a slightly different route. What do you know? Well, what we're looking at here is where we've got our budget line, x, y, and we've got the slope of this budget line, as always, is the ratio of prices, but our indifference curves are right angles. They look like that. What do we know? At our optimum point, what we're going to have is we're going to have x and y being consumed in a way that those two numbers have to be equal. So what does that mean? Well, 2x is going to be equal to 4y, or x is equal to 2y. Divide each side by 2. So now we have, just like we had in the Cobb-Douglas case, our x as a function of y. Now we can just go to our budget constraint and plug that in. Our budget constraint is the income, 100, minus the price of x, 2, minus the price of y is 1, so that's going to be equal to 0. So plug that in right there. X is equal to 2y. So we have 100 minus 4y, 2 times 2 is where the 4 came from, minus y is equal to 0. 100 is equal to 5y, and that tells us the optimal amount of y is 100 divided by 5 is 20. How much x are we going to consume? X is equal to twice that. X is equal to 40. So that is going to be the optimal mix of x and y. Plug those into our function up here. We have 2x is equal to 80. Y is equal to 4 times 20, also equal to 80. So what's our utility going to be equal to? Indirect utility is the minimum of 80 and 80, which is 80. That's the solution.